Hi, I'm M.R. Morrison and I'll be your instructor for this course. But first and foremost, I want to thank you for considering my course to pursue your training in Postgres database. I've been a database administrator for over 7 years. One of the main reasons I was compelled to develop this course for you was that when I started out with Postgres database administration, it was very challenging in finding a course in Postgres that was geared towards database administrators. Majority of them were geared towards developers, and chances are you're experiencing the same problem. But don't worry, as this course will teach you all you need to manage Postgres database successfully. If you're a beginner or an experienced DBA, this course is ideal for you to get your skills up and running. Up next, we'll be taking a brief look at what is Postgres database. So what is PostgresSQL? PostgresSQL is an open source database that has a strong reputation for reliability, flexibility, and support open technical standards. Unlike other relational database management systems, Postgres supports non-relational and relational data types. This makes it one of the most compliant, stable, and mature relational databases available today. PostgresSQL is a highly scalable database backed by more than 20 years of development by the open source community. It is also a primary database for many web applications as well as mobile and analytics applications. Common uses of PostgresSQL include a robust database in a lab stack. Lab stands for Linux, Apache, PostgreSQL, and PHP, or Python or Perl. PostgreSQL is primarily used as a robust backend database that powers many dynamic web applications. Secondly, it's a general-purpose transaction database. Large corporations and startups use PostgreSQL as a primary database to support their applications and products. Because it's open source, they can save on license costs when they go open source. Thirdly, as a geospatial database. PostgreSQL with the PostGIS extension supports partial databases for geographic information systems. PostgreSQL has many advanced features that other enterprise-class database management system offers, such as user-defined types, table inheritance, sophisticated lock-in mechanism, foreign key referential integrity, multi-version concurrency control, asynchronous replication, table spaces, point-in-time recovery, and more new features are added in each release. PostgreSQL is designed to be extensible. It allows you to define your own data types, index types, functional language, and much more. If you don't like any part of the system, you can always develop a custom plugin to enhance it to meet your requirements. In the next lecture, we're going to be taking a look at how you can set up your environments. In order to set up our test environment, we're going to need a couple tools. The first one is PGAdmin for administering our database. The second one is Oracle VirtualBox to set up our virtual machines, and Ubuntu ISO image to set up our Linux server, as well as a Windows ISO image or OVA file to set up our Windows server. So guys, the first tool that we're going to be downloading and installing is PGAdmin. So you can go to google.com and search for PGAdmin. Select the first link that pops up. Select the downloads page. PGAdmin is cross-platform, so if you're on a Mac or a Windows server, you can download PGAdmin. So I'm on a Windows, so I'm going to go with the Windows version, right? So I'm going to select this link, and I always go with the latest release, so I'm going to download the latest release here. So now I'm just going to download the executable file. This may take a minute or two to complete. Once the download is complete, open the executable. I'm going to install for me only. Select next to continue. Accept the terms and agreement. Select next. You can change your installation directory. The default is fine. Select next. Select start menu folder. Keep the default. Select next. And then select install. The installation will take a minute or two to complete. So the installation has been completed. Now select finish. So we are not going to be using the PGAdmin immediately. If you're not familiar with PGAdmin, PGAdmin is the management tool that we'll use to manage our databases. So we'll use it to interact with our database for majority of the course. In the next lecture, we're going to be going deeper into setting up our environment by downloading the Oracle VirtualBox. So to get started with Oracle VirtualBox, go to Google and search Oracle VirtualBox. Select the first link, scroll down, select Downloads, and select the platform package for the operating system that you're using. I'm going to select the Windows OS. This will take a minute or two to complete as well. Once the download is complete, open the executable. Select Next. Keep the default and select Next. Select Yes. Missing dependencies, Python core. Select Yes. And then select Install. Select Finish to start the VirtualBox after installation. So this is what the VirtualBox application looks like. In the next lecture, we'll be downloading the Ubuntu operating system. For this course, we'll be using the desktop version and not the server version. In this lesson, we're going to be downloading Ubuntu operating system and installing Postgres. So to get started, head over to google.com and search for Ubuntu. Here, select Download Ubuntu Desktop. Scroll down and grab the latest version. So once you selected the latest version, your download will be automatically started. If your download has not been automatically started, you can select download now. So the installation has been completed. Now head over to your Oracle VirtualBox. So you're going to select new, specify a name for your server. So I'm going to call this Postgres-SVR. Browse for the image that you downloaded. So here I'm selecting the Ubuntu desktop, select open, and then select next. So here we're going to change the username to Postgres, and for simplicity I'm going to set the password to Postgres as well. Select next. Here you can choose how much memory you want to allocate to your virtual machine. I'll be allocating 4 CPU and approximately 5 GB of RAM. Select next. I'm going to reduce the hard disk size to about 10 gigs. Then select next. And then select finish. So it's now powering up the virtual machine to complete the installation. Select enter to try or install Ubuntu. Select your language. And then select next. So we're going to be selecting the option to install Ubuntu. Select next. Select detect your keyboard. Here you're going to choose your keyboard layout. I'm going to select English US and then select next. Here I do not want to connect to the internet, so I'm going to select this option here. I don't want to connect to the internet just now. Select next. Select next. Here we have an update available. You can install it if you wish. I am going to skip it. So here I'm going to keep the default installation and select next. Here select erase disk and install Ubuntu. So select next to proceed. Select install. Select your location and select next. So for simplicity, for your name specify Postgres. For the username keep Postgres. And for the password you can set it as Postgres. So here I'm going to change this option from require my password to login. I'm going to turn it off, so you can go ahead and turn it off. Select next to proceed. You can choose your theme and select next. So it is currently setting up the system. This will take a few minutes to complete. Select restart now. So now that the installation has been completed, we need to configure our server so we can access it remotely, meaning we can access it from our laptop. So what we're going to do now is that we're going to be setting a static IP. So you want to select the network icon here. Click this little arrow here. Select wired settings. Select settings. Select IVP4. Select manual. Now in order to know which IP address we are going to be setting, we are going to be launching your command prompt and check your IP or the network which your computer is on. So for Windows user, it's cmd and the command is ipconfig. So this is my IP, and what we're going to be changing is the last octet for our server. So I'll be using 192.168.2.112. For the network mask, it's 255.255.255.0. So you're keeping the same network mask and the same gateway. So it's 192.168.2.1. Remember, the information you should use is what's on your machine, not the one that I'm using in the course. Disable DNS and specify the same IP address for the gateway. So it's 192.168.2.1. Now select apply. So enable and disable the connection. Now the next step is to select machine, select settings on your networks tab. From the drop down, select bridge adapter, expand advanced, and select allow all. Select OK. Now let's reboot the server. So it start. From the home screen you can select terminal and then type reboot. So let's skip online accounts. I do not want to send any info. Select next and select done. In order to test if the changes that you have just made are working, launch the command prompt, so it's cmd command prompt, and ping the IP that you configured on the server. So it's 192 in my case, 168.2.112. Now once you're getting a reply like this, that means your configuration was successful. Now we have one more step to go before we can SSH to our server. So go back to the server, select show apps, select terminal. So now we're going to install the OpenSSH. So it's sudo apt-get install OpenSSH server. Hit enter, specify your password, select yes. Now the next step is to check the status of the OpenSSH. So the command is sudo service ssh and then status. In order to check the status of the SSH service, so that should return the status of the SSH service. So here it's active and running. So now we can remote to our server. Now the reason why I'm taking you through this route is because I want to simulate connecting to a server in the real world, right? I could have easily gone and installed the Postgres server on my laptop, but we will not be getting the real world experience if I had taken that approach. So the next step is that we're going to be connecting with an SSH tool called PuTTY. You can download it from this website here, and you can just simply Google download PuTTY and it will take you to this website, right? This application is already on my machine, so I'm just going to launch it. In order to connect, you're going to specify the host name or IP. So it's 192.168.2.112. That's my IP. Specify your username, which is Postgres in my case, and my password is Postgres. So I've been successfully connected to my server. Now to increase the font, you can right click anywhere on the screen, select change settings, select appearance. Here under the font settings, select change and you can increase the font. I'll be selecting 14 and selecting OK. Then select apply. You can also change the text color for visibility, right? So you're going to go back to settings. So you right click again, change settings, select colors, select the default foreground color, select modify, and here I'm going to go with this nice green color and select OK, then select apply. Now we're going to be installing Postgres. So the documentation that I'll be using will be linked in the resource section of this lecture. So let me minimize my screen. So on one side I'll be keeping the documentation and on one side I'll be keeping my terminal. So the first step, we need to create the repository configuration. So this documentation will be available in the resource section, guys. So it's just copy and execute. Specify the password for Postgres. After you create the repository configuration, then you're going to import the repository sign-in key. So all the commands are available for you guys. Let's copy and paste, enter. That's done. Now let's do an update. Hit enter. This may take a minute or two to complete. Now let's run the command to install Postgres. Select Y to continue. It's now installing the client. So the download is still in progress. And the speed of this, guys, will be dependent on your network speed. So the installation is complete. Now we have one last step to complete. So now let's install the PostgresSQL contrib package. Now we can check the status of PostgresSQL. So the command is sudo system status ctl. So the service is in an active state. To stop the service, you do systemctl stop PostgresSQL. To start, you do sudo systemctl start PostgresSQL. So that is pretty much how you'll stop and start and check the status of your database instance. To clear your screen like I just did, you type the clear command and hit enter. Now from the command line, you can test connectivity to your instance by using the PLSQL client. So it's PSQL. So now we are basically successfully connected. To do a basic query, you can list all the databases by doing a /L. And this lists all the databases that are currently on the instance. To exit, type /Q. In the next lecture, we'll be taking a look at how we can install Postgres on a Windows server. Before we attempt to connect to our Postgres database server from the client, we need to understand a little bit about the configuration files on Postgres. First, we need to take a look at the configuration files on Postgres. So there are two main config files on Postgres. First, you have the PostgresSQL.conf. This is created automatically when you install PostgresSQL. This config file basically affects the behavior of your instance. For example, if you want to change the number of clients that can connect to your database, you would have to change it in the PostgresSQL conf file. All of this have a default value when the database is installed, but you can change these values to better suit your workload and working environment. The most basic way of setting these parameters is to edit the PostgresSQL.conf file. However, since version 9.4, PostgreSQL introduced a new configuration file, the PostgreSQL.auto.conf. It's worth noting that the autoconf must be modified using the alter system statement in PostgreSQL, and the PostgreSQL.conf can be modified using the basic text editor. To show the location of this configuration file, you would use a show config_file. In order to connect to the database, one of the main parameters we need to change in the config file is the listening addresses, because by default, Postgres is set to listen on the local host. So we need to replace the local host with another IP that we want to allow connection from. The second config file that we want to take a look on is the pg_hba.conf. The pghba.conf file handles the default authentication options for client connections to the database. So in the config file, it takes the form of the type, the database, the user, the address, and the method. Each entry specifies how matching requests are authenticated. So by default, if you type PSQL at the command line on the host where PostgreSQL is running, peer authentication method will be used. It will attempt to log you on as the database user whose login matches the current logged in Linux user. When you're logged on to the server as Postgres, when you're trying to connect to the database, this configuration file will automatically map back your user to the database user and authenticate you as that user. So if you wanted to require password authentication by default, all you need to do now is set the method field for the local entry to password. To allow a remote user to log into the database using a non-hash password, you can add a new line to the file. So in this example, you would have the host name. You can specify a specific database or all the databases, the login user, their IP, and for the method, specify MD5. Both the PGHBA file and the PostgresSQL.conf file are in the same directory. In the next lecture, we are going to attempt to connect to our database as a client or a remote machine. If we attempt to connect to our database server now, the connection should fail. So right click, register, server, specify a name for your connection, specify the host name, and currently we don't have a password, but let's try connect and see what error message we'll get. Connection failed, timeout. So now let's make the necessary configuration within our config files to accept connections. First, we need to identify the location of our config file. So on the terminal, type PSQL, and the command to show the directory is show config_file. Both the HBA config file and the PostgreSQL file are in the same location. Exit by typing /Q, change directory, do a LL to list the files within your directory. Now the first step is to do a backup of the file that you want to change. We're going to change the PostgreSQL connect file first. So highlight, paste, and then specify a name for the backup. I missed a command, cp. Now edit the original config file. You want to scroll down and search for listing addresses. You want to uncomment the line. And remove localhost and specify all addresses. So you would use the asterisk to do that. Additionally, you could specify a list of addresses and separate them by a comma. The next thing we want to change is the authentication method. We want to enable it. So if you scroll down, you should see authentication and then uncomment password encryption. So it's either scram SHA-56 or MD5. Once you make the necessary changes, escape, W and then Q. The next file we want to edit is the HBA config, so we need to take a backup, cp, copy the file and specify the backup file name. Now VI to edit, and for testing purposes, we're going to allow connection from all IPs. So simply change the 127 to 0 and change the 32 to 0. The authentication type can be Scrum or MD5. We're going to use MD5. This is pretty much saying the user needs to specify a password when they are connecting. So if you don't want the user to specify a password, then you could specify trust. So to save the file, press escape, W and Q. Now let's restart Postgres to make the changes take effect. Select the user to restart. Specify your password, and the last thing we need to do is set the password for the Postgres user. So we need to connect to Postgres again by typing PSQL, and to change the password we need to alter the user, Postgres, and set the password that you want to connect with. Now let's try connecting again. So specify the password, select save. So my attempt to restart the server initially failed, so let me redo it. Restart 1, specify the password. Authentication is now complete. Now let's try connecting to our database. So specify the password that you just set and try connecting to your host again. And we're in. So that's pretty much how you configure your config file to able to connect to your Postgres database. In the next module, we'll be taking a look at managing our databases on Postgres. In this lecture, you'll learn how to use PostgreSQL create database statement to create a new database in PostgreSQL database server. The following shows the syntax of the create database statement. To To create a database in Postgres, you need to have super user role, permission, or a special createDB privilege. When creating a database, the name must be unique. If not, Postgres will throw an error. When creating a database, assign a role that will be the owner of the database. If you omit the owner option when creating the database, the owner will be the role that you use to create the database. Also specify a template database from which the new database is created. By default, Postgres uses the template 1 database as the template database if you don't explicitly specify the template database. Also specify the encoding parameter. This determines the character set encoding of the new database. You also have the LC collate. When you specify this parameter, it affects the sort string of queries contained in order by clause. Its default is LC collate. Its default is the LC_C type of the template database. When you're creating databases, your database files must be stored in a table space, so you have to specify the table space for the new database. If not specified, the default will be the table space of the template database. When you specify the connection limit, it determines the maximum number of concurrent users that can be connected to the database at a single time. The default is -1. That means you can have unlimited connection. So if you specify like 100, then the maximum number of concurrent users will be 100. If you do not want to allow any connections to the database, then you can set the allow connection parameter to false. Another important parameter is the is_template. If the is_template is true, any user with a createDB privilege can clone that database. If it is false, only super users or the database owner can clone that database. When you're creating a database, if you don't specify these parameters, they will take the default of the template database. So let's take two practical examples of creating a database. We're going to be using two methods to create a database. First, we're going to be using the terminal with PSQL, and the second option, we're going to be using PGAdmin. You can always check if your database service is running by typing service PostgresSQL and then status. Oh, I missed a T. So if you look carefully, it will say active and status success. So to access your database, you need to type PSQL on the terminal. First, we are going to create a database without parameters. So we're just going to easily create database command and specify the name of the database. To view the list of the databases, do a /L/L, and you should see the database listed out. If you look carefully, you'll see that the demo DB has the same parameters as the template 1DB, because by default, when you don't specify any parameter, it will inherit from the template 1 database. The second database we are going to create is that we are going to create one where we specify the connections. You see the same command, only difference is that you are going to specify a width and specify the parameters that you want to change. So let me hit enter and my database is created. So if I do a / again, L, I should be seeing the new database that I just created. So I see demo param. Now let's head over to PGAdmin and create a database using the graphical user interface. To create a database using PGAdmin, right click database, over create, select database, specify a name for your database. On the definitions tab, this is where you can specify the different parameters. So I'm going to put 10 for my connection. If I wanted a different collation, then I could select another one. So I'm going to go with UTF-8. Note if I choose a different one and enable template and try to save, it will give me an error. Specify here table space. I'm going to use PG default. In another module, we'll be covering table spaces. On the securities tab, you can grant other roles permission to the database. You do that by selecting add and then expand security and select the role that you want to grant the permission. On the SQL tab, you'll see the script that will be used to create the database. As you can see, the width, the owner is Postgres, the encoding, the else equal late, the table space, the connection limit, and the is template. So I'm going to enable the template DB and change back the collation to UTF-8. Then select save. In the next lecture, we'll be taking a look at how we can modify and alter our databases. In this lecture, you will learn how to modify an existing database by using PostgresSQL alter database statement. The alter database statement allows you to carry out the following actions on your database. 1. Change attributes of the database. 2. Rename the database. 3. Change the owner of the database. 4. Change the default table space of the database. 5. Change the session default for a runtime configuration variable for the database. In order to change attributes of the database, the command take the following form. First, you have the alter, which is the action that you want to perform, right? And then you have the name of the database that you want to change. And then you have the with option to specify the option that you want to change on the database. As mentioned earlier, when you were creating the database, there are several attributes that you could have specified. So to change these attributes with the alter command, you will simply use the with option. So some of the options that you can change is the is template, the connection limit, and allow connections. It's very important to note that only super users or DB owners can change these settings on the database. From time to time, you may need to rename a database. The syntax to do this is really simple. The syntax follows the format alter, then the database name, and then you simply say you want to rename it to, and then you specify the new name that you want to change it to. It's very important to note that when renaming a database, you can't rename the current database. You have to connect to another database and then rename that database. Also, you'd have to kill any running session that is on the database that you want to rename. So, some of the time, if there are processes connecting to the database repeatedly, what you would have to do here is limit the connections to 0 and then kill all the active connections that are on it. Also, only super users and database owners with the CreateDB privilege can rename the database. If you try with a user that doesn't have the privilege, they will get an error. In the next lecture, we'll be taking a look at how you can change your database owner. You may also want to change your database owner from time to time. To do this, you issue the alter database command, right? Specify the name of the database and the owner too. So you can specify the owner which you want. So you could also specify current user to use a current user that is logged in, right? Or the current session user. In order to change the DB owner, you have to have the CreateDB privilege or a super user like Postgres. In the next lecture, we'll be taking a look at how we can alter our database to use a different table space. When managing your databases, it's a great idea to have separate table spaces for each database. So let's say you created your database in the default table space. You could use the alter database command to move the database to a new table space. So it will go with the syntax, say alter database, specify the database, and then set table space and set the name of the table space. So what this statement does is that it literally moves the tables and indexes from the old table space to the new one. So if you're supposed to go on the database server and check the directory of the new table space that you're moving the files to, you'll actually see some database files in that folder. So the privilege required to do this is that you have to be a super user or you have to be a database owner, just like the previous operations. In this demo, we're going to be altering our database. You can use either the terminal or PGAdmin. So if you're using PGAdmin, the method doesn't really matter because you're going to get the same end result. So we're going to be attempting to rename in the DemoDB. Select the DemoDB, right click, scroll down to Query Tool. So the first thing we are going to be doing here is that we're going to be changing an attribute on the database. So it's altered database, right? Specify the name and with the option that you want to set. So we're going to alter the DemoDB and change the connection limit to 20. So it's alter database, specify the database name, right? So it's demo. So it's DemoDB, and width we want to change the connection limit, right? So we're going to set that to 10. Now hit the play button to execute, or you can hit F5. Database altered successfully. Now let's right click on the database, view properties, right? If you go on definition, you'll see the connection limit set to 10. So what we're going to do now is that we're going to attempt to rename the DemoDB. So it's alter database, specify the database name and the action that we're going to perform, which is a rename. But I don't expect this to work because you cannot rename a database where you are connected to that session. So let's highlight the statement and hit execute. So that was a syntax error. I messed out the two. So rename to and specify the database name. So let's highlight and execute. Current database cannot be renamed. That's because we are connected to the database. However, if we attempt to rename the demo param database, we should be able to rename it successfully. Select highlight and execute. So as you can see from the output message, the query returned successfully. So let's do a refresh on our database. Now you see the database name is being reflected as new DB. Once you're connected to the database, you cannot rename it. You would have to disconnect your session. So let me copy, close this session, right? Don't save. Now let's go to the Postgres database query tool. And now we're going to rename the DemoDB to new DB underscore test. Execute the statement. So it shows an error. DemoDB is being accessed by two other users. So I would have to kill these users' session to be able to successfully rename the database. We can query the PG activity stats to see a list of sessions that is connected to our server. Once we have the PID of the sessions that we want to kill on the DemoDB, then we can use the PG terminate backend function to get that done. So these are the two PIDs that we need to kill. 1668, right? So let's run this command here. The result is true. So let's execute the PG stat activity again. Now you realize that that session is gone from the database. Now let's kill the other session. 1901. Let's check the stats again. So all the sessions are gone, so we can successfully rename the demo database to new test DB. It's very important to note this because you may be trying to rename a database but realize you can't rename it and don't know why. So you can't have any active session on the database when you're trying to rename it. So as mentioned earlier, if this is an active database where users are connecting frequently, then you'd have to set the connection to 0 so no one can access the database, and then you kill those sessions. If we wanted to change the owner of the database, all we need to do now is do alter database, right? Then we need to say owner to, and then specify the owner that you want to change the owner to. So I'm going to use demo user and then execute the statement. So new test DB did not exist. The earlier when I killed the session, I did not execute the command to rename it, so that should be good now. So let's execute. Database altered. So let's check the owner of the databases. So right click on databases, refresh, then select new DB, select properties. Right now on the owner you would see demo user. In the next lecture we're going to be taking a look at how we can drop a database in Postgres. At the end of this lecture, you should have an understanding of table spaces in PostgresSQL. A table space is a location on the disk where PostgresSQL stores data files containing database objects such as your indexes and tables. PostgresSQL uses a table space to map logical name to a physical location on the disk. So if you check the disk location of your table space, you should see some files in the directory. There are two default table spaces that come with PostgresSQL. You have the PG default table space as well as the PG_global table space. These two table spaces are automatically created when the database cluster is initialized. PG global table space is used for shared system catalogs. The PG_default table space is the default table space for the template 1 and the template 0 databases. So pretty much when you're creating a database, if you don't change the template database or specify the table space location, the default table space will be that of the PG default table space. Once a table space is created, any database can use that table space, given that the user has sufficient privilege to access it. This means that a table space cannot be dropped unless all the objects in the database using that table space have been removed. So table spaces pretty much allows you to control the disk layout of your PostgreSQL database files. So there are two main advantages of using table spaces. The first is if the initial partition or disk where the cluster is initialized is out of space, you can create a new table space on a different partition. However, once this partition is created, it doesn't automatically solve your problem. You'd have to move an entire database or couple large index or table to this table space to free up some space in the initial table space that is running out of space. The second advantage is that when you have multiple table space, right, and you analyze your database and you see that this a specific table or index is accessed frequently, you can now put that index or table on a separate solid state disk to improve performance. Or you can also put rarely accessed data or archived data on a separate partition which contains slower disk or cheaper storage. If you're familiar with Oracle table spaces, particularly small file table spaces, and your table space is full, you can add another data file. However, this is not the case with Postgres. You would have to extend the underlying file system, right? However, it is similar to the big file table space in Oracle, where you can only have one file in the table space. If the file system runs out of space that holds a large file, you'd have to expand the file system to be able to allocate more space to the table space. Unlike the small file table space, you can add a data file and add it to another mount point or drive. In the next lecture, we're going to be taking a look at how you can create a table space. To create a table space in Postgres, you will use the create table space statement to create the table space. It's very important to note that the table space should not begin with PG underscore because this is reserved for the system table spaces like the PG underscore default and the PG global. So by default, the user who executes the create table space is the owner of that table space. So if you want to assign a specific user to own that table space, you have to specify the owner keyword. The directory path is the absolute path to an empty directory used for the table space. Postgres system users must own this directory in order to read and write data into it. So if you created a Postgres user, the Postgres user must have read and write permissions on that directory. So once you have created a table space, when you're creating a table, a database or an index, you can specify which table space you want the objects to be stored in. So let's look at an example of creating table spaces. And it's ideal to have a table space for each database that you have on the database server. So let's look at a demo in how you can create a table space using PGAdmin. Before you can create a table space, you want to ensure the directory for the table space exists before you try creating the table space on Postgres. So we're going to create a table space for the new db_test. So I'm going to go over to the Linux terminal. Normally you would have dedicated mount points to store your database file. However, because this is just a test machine, I'm going to be creating a folder that will be acting as a mount point. So I'm going to call it data2. And within that data2 folder, I'm going to have /tablespace and then the folder for the actual tablespace of the new DB. So to create the directory on Linux, you can type mkdir -p, that will create the subdirectories within the top folder, which will be data2, then tablespace, and then new db2. So I need sudo permission to create the directory. So if I do ll on this directory, right, you would realize that it is the root who owns this directory, and Postgres is the system user for the Postgres instance. So I realize I spelled tablespace incorrectly, but that's fine. So I need to give Postgres permission to write to that directory. So I'm going to make the default group as well as the owner Postgres. So to do that, type chown for change owner, right? And I'm going to be assigning the group as Postgres and the owner as Postgres. So if I do the ll now, I should be saying Postgres as the group and Postgres as the owner, and it has read-write access. Now we need to grab this path and go back to PGAdmin to create our table space. So you have two ways to do this. You can generate the script, right click on table spaces, over create, then select table space. Specify the name for the table space. So I'm going to call it new db2. And for the definition is where you want to specify the location for your table space. And then hit save. So if I want to see the actual script that was used to create this table space, I can right click, create script, right? Here you have the script that was used to create the table space. You have the create table space, the name of the table space, the owner, and the location where the files will be stored. Now let's do a check in the directory of the table space. So let's do a ll table space directory, and you can see, and this is the directory which was created. Now you can set the default table space of the new db_test. So right click, select properties, then under definition you can change it to new db2. Then select save, and my table space has been changed for the table. So once new tables and indexes are created in this database, the objects will be stored within that table space. In the next lecture, we'll be taking a look at altering table spaces. In this lecture, you'll learn how to use PostgresSQL alter table space statement to rename, change the owner, or set the parameters of a table space. Let's say when you are creating your table space name, you made an error and you wanted to correct it, or you renamed your database and you want to rename your table space to reflect the same as your database name. Now, you don't have to panic. You can literally use the alter table statement to rename the table space. So you use the alter table statement, specify the name of the table space that you want to rename, and specify the new name that you want to rename it to, and then you execute. And the table space has been altered. Now if you refresh table spaces, you should be seeing your table space now being reflected as the new name you specified. By default, when you're creating a table space, if you don't specify the owner of that table space, by default the owner will be the creating user. However, if you want to change the owner of the table space, you can use the alter table space command again and change the owner too. So I want to change the new table space owner to the demo user that is on the database here. So execute. If we go on properties, we should be seeing the demo user as the owner. Now you can also change the owner from the drop down. So if you select Postgres, then select SQL, you'll see this statement it will generate to change the owner, as well as you can rename the table space from here. So let's rename it back to demo. Select save, and all the changes should be reflected. So if you hit properties, you should be seeing the new changes that you just applied. In the next lecture, we'll be taking a look at how you can drop table spaces. Dropping a table space is something that you'll rarely do in a production environment or even a test environment, but it's still important that you know how to do it in the event that you need to drop one. To drop a table space in Postgres, you would use the drop table space statement to remove a table space. You can also use the if exists option to instruct Postgres to give you notice of an error if the table space does not exist that you are trying to drop. Only table space owners and super users can execute the drop table space statement to drop a table space. So now let's head over to PGAdmin to simulate how you drop a table space. So connect your database again, and we are going to attempt to drop the demo DB table space. So right click on the Postgres database, select query tool, and then type the drop table space command. So it's going to be demo db. Now I'm not expecting this work because you cannot drop a table space that is not empty. So before we can drop the table space, it has to be empty. Now let's check our databases and see which databases are using this table space. So it's a new DB. Now we have to change the table space after new DB. So let's set it to new DB2 and save. Now let's attempt to try and drop the table space again. The table space has been successfully dropped because we have removed the database from that table space. So there is no more dependency on that table space. So you are free to drop it. This is to really protect you because you don't want to drop your table space and then your database or your application starts screaming and say, hey, where's my table space? You don't want that to be happening to you. In the next lecture, we'll be taking a look at roles and privileges. PostgreSQL manages database access permissions using the concept of roles. It doesn't use a user concept like other database systems. A role can be thought of either a database user or a group of database users depending on how the role is set up. Roles can own database objects such as tables and functions, and can assign privileges to control who has access to which object. That's pretty much saying if I own a object, I can then grant another user access to the object I own. It is also possible to grant membership in a role to another role. So when a role contains another role, they are called group roles. So typically, roles that can log in are called login roles. They are pretty much equivalent of users in other database systems. A role in Postgres, you'd use the create role statement. So let's create a role called demo user. So it executes to create the user. Now if you expand login/database roles, you should be able to see the demo user that we just created. You can also query PG roles to view the list of roles. So I highlight. So this is a list of roles and it is listed in order of which they were created. So you can see the demo_user as the last user. Notice all the system roles starts with a PG_. If you're on the terminal, you could do the same thing using PSQL using /du. To simulate being on the terminal, right click on any of the databases and then select PSQL tool. Then type /du. Then enter and you'll see the same information reflected here. So if you look carefully, the demo user we just created cannot log in. That's because we did not assign it the attribute to be able to log in. So in order for the user to be able to log in, we need to assign it the login attribute. When creating a role, you can define various privileges for that role, such as login, super user, database creation, or role creation, password, and more. So when you're creating a role, you can specify more than one options in the create statement. Now let's create a user that will be able to log in to the database. So first we need to specify the create role, specify the username, and then you're going to specify the options that you want. So we want the user to be able to log in, and we also want to set a password for that user. To set the password for the user, you're going to just specify the password in single quotes. Do not specify a equal sign. Once you have done that, select execute. So my demo user already exists, so let me specify one to the name and execute again. Now it's completed successfully. If we go back to the PSQL and then type /du, then you'll see our demo1 user, but this time it does not have the option that it say can't log in. So if you try to connect to the server now using demo user _1, you should be able to get into your server. From time to time, you may also need to create additional super user, but bear in mind the super user can override all access restrictions within a database, so therefore only create this user when it's really needed. So to create a super user now, all we need to do is add the super user attribute to the create user statement. So let's specify super user, and we're going to change it to demo super. Execute. Remember, you can also query the PG roles to see the information. So on the PSQL, I'm going to type /du. Now you see that my demo super has the super user attribute. If you wanted to create a user that have enough permission to create like just databases, then you can create a user with the create DB attribute. So let's copy and paste. And you can change the user from super to create DB. Let's say you want a user that can create databases, but you don't want to give them the full super user permission. What you can do now is just create a role and assign them the create DB role. So let's copy this statement. We can call this role demo DB creator. And instead of specifying super user, you say create DB. Execute. You can query the list of users /du, that's for databases. And now you see that the demo DB creator has the create DB attribute. You can also create roles using the graphical user interface. Right click roles, create login role, specify the role that you want to create, and then you can specify the privilege. Do you want the user to be able to log in? Yes. You can also specify when a user login expires. So select on the definition, and then under account expire section, select the calendar, and then select the date that you want the user to be expired. Now this is essential when you're creating temporary users that will only need to have access to the database for a limited time. Now you can also set the connections to say only 3 or 1 if you only want one session from that user to be able to access the database at any given point in time. If you select on SQL, you should see the statement that it will create. So select save to continue. To see a list of users again, you can do the /du. Now you should be seeing the limited user with one connection as the attribute being assigned, as well as the expiry date of the password. So in Postgres, user roles represent user accounts. A role that can log in is equivalent to a user account in another database system. You can use the role attribute to specify privileges of the role. In the next lecture, we'll be taking a look at granting privileges and database objects to a role. In this lecture, you'll learn how to use PostgresSQL grant statement to grant privileges on a database to a role. After creating a role with a login attribute, the role can log into the Postgres database server. However, it cannot do anything on the database objects like the views, functions, and tables. So the user cannot execute a specific function or query a table. To allow the user role to interact with the database objects, You need to grant privileges on the database objects to the user by using the grant statement. So here's an example of what the grant statement looks like. First, you'd specify the privilege list. This can be select, insert, update, delete, or truncate, etc. right? You can use the all option to grant privileges on a table to a role. Then you need to specify the on keyword because you need to specify which object you're granting after the on keyword. Then you specify the name of the role which you want to grant the privileges to. In order to grant privileges, you need to be a super user. So now let's head over to PGAdmin for a tutorial on how you can grant permissions to roles. In the previous lecture, we created the demo user which was able to log in. So now connect to your database server as the demo user. So right click on server, over register, then select server, specify a name for the connection. I'm going to call it demo user. For the connection details, specify the host name or IP of the server. For this demo, I'll be using a DVD rental database, which I'll leave a link for you to download and restore to your test environment. So you're going to connect with the demo user. Specify the password and then save. So in my DVD rental, I have some tables which are in my public schema. So if I right click on any of these tables and then select script to select and then execute, I should be seeing a list of data within my table. Now if I copy the same script and connect to the demo user, expand DVD rental, right? Then right click and select query tool. If I paste this, then I'll get a permission denied for a table because I don't have permission. So what you need to do now is grant the user access on that schema. So to do that, you should use the grant command as a super user. So switch back to the Postgres session. So specify the grant command, the operation you want to grant, which is select. Then you want to say on, and then you specify which schema. It is public category, right? And then you're going to specify to whom you want to grant the permission. So it's demo user. Now select execute, delete that semicolon. Now select execute. If we go back to DVD rental session and then execute, the user should now be able to access the data. If the user attempts to do an insert, then the operation will fail. Permission denied for a table category. So now go back to the Postgres session and grant the user insert on the table. Now if you go back to the Postgres session and do a if you go back to the Postgres session and execute the insert statement, it should succeed without any errors. Then when you go back to the demo user session and execute the insert statement, it should succeed. And you'd repeat this for insert, update, and delete, whichever permission you want to grant. If you have a schema with multiple tables and you want the user to have access to all the tables in the schema, then granting the user permission on individual objects wouldn't be ideal. What you can do, or what you should do in this case, is grant the permission at the schema level. So you say grant select on all tables in schema, specify the schema name, and to the user. It's also important to note that you can grant multiple privileges in a single statement. So you could say grant, insert, and update in a single statement. So if we execute this, it should complete without any errors. In the next lecture, we'll be taking a look at revoking permissions. Once you have granted privileges, you may need to revoke some of them or all of these privileges. To do this, you can run the revoke command. You can revoke any combination of select, insert, update, delete, truncate, references, trigger, or even all. The syntax for revoking privileges on a table is as follows. First, you specify one or more privileges that you want to revoke. You can use the all option to revoke all privileges. Secondly, specify the name of the table or object after the on keyword. And thirdly, specify the name of the role which you want to revoke the privileges. So let's take a look at a quick demo of how you would revoke privileges from a user on the database. So let's revoke the select permission from the demo user. So instead of using grant, just change the grant in your statement to revoke. And instead of using to, then you specify from. Then execute the statement. Now if you attempt to query the category table as the demo user, you should be getting permission denied. So let's execute. As you can see, permission denied. If you query another table within the same public schema, then the user should be able to still be able to access it because you only revoke the permission from a specific table. To revoke all the permissions, you could use the revoke statement and then specify on all tables within the schema. So if we execute, it should complete successfully. You could also use the revoke all, which would revoke all the permissions completely from the user. If you go back to the demo user session and execute the query again, you should be getting a permission denied. In the next lecture, you'll learn how to use the alter role statement to modify attributes of a role. In PostgresSQL, the alter role statement is used to manage and modify roles. It can be used to modify the name of a role, the attributes of a role, and alter a role session default for a configuration variable. It follows the syntax alter, role, the role name, right, and then the with option. The options that can be changed are super user or no super user. This determines if a role is a super user or not. You have a create DB or no create DB. This pretty much allows a user to create databases. You have a create role, no create role. This allows you to change or create roles on the database. Inherit or no inherit. This determines if a role can inherit privileges of roles of which it is a member. Login or no login. This allows the user to be able to connect to the database. Replication or no replication. Determines if the role is used in replication roles. Bypass SRLS or no bypass SRLS. It is used to check if a role can bypass a role level security policy. Then you have a connection limit, which specifies the number of concurrent connections a role can make. Password with a password or password null can change a user's password. And last but not least, you have the until timestamp, right? It is used to specify the expiry date and time of a role's password. The following are rules that must be followed when using the alter role statement. Super users can modify the attribute for any role. Ordinal roles can only change their passwords. Rules that have the create role attribute can change any of these attributes for non-super users or no replication rules. If you want to drop a role in Postgres, you would use the drop role statement. So what you need to do is specify the name of the role you want to drop after the drop role keyword. To remove a super user role, you need to be a super user. To drop a non-super user role, you need to have the create role privilege. When you remove a role reference in any database, Postgres will raise an error. In this case, you have two steps you can take. First, either remove the objects owned by the database role using the dropped own statement, or reassign the ownership of the database objects to another role using the reassigned owned statement. Secondly, you can revoke any permissions granted to that role. So what the reassigned owned statement does is that it reassigns ownership of the dependence object of a target role to another role. So because the reassigned owned statement can only access objects in the current database, you need to execute this statement on each database that contains the target role. So after transferring ownership of the objects to another role, you need to drop the remaining objects owned by the target role by executing the drop owned statement in each database that contains the objects owned by the target role. So in other words, you need to execute the reassigned owned statement first, then the drop owned by the role, and then you drop the role. So now let's take a look at a practical example. Connect to your Postgres database server as the demo user and connect to the new DB and create a new. Ensure that the owner of the database is the demo user. So you can right click properties and check. So create a demo table. So now connect as a Postgres user and try and drop the demo user. Open the query tool and try to drop the demo user. So it's drop role and the user name, which is demo user. Then you execute. If you look carefully at the bottom of the screen, you will see the arrow. Role demo user cannot be dropped because some objects depend on it. Detail, owner of database, new demo test. It also owns object in the DVD rental and also owns objects in the new DB. So what you need to do to resolve this issue is connect to each database and then execute the reassigned own statement. So once you have done that, the next command you need to execute is the drop own by command and then specify the owner. Now we need to repeat this on the DVD rental database. So go back to the Postgres session now and try to drop the demo user. The role has been dropped successfully. It's important to note that if a role has dependent objects, use the reassigned owned and use the drop own statements in sequence to remove dependency of the objects of the roles before executing the drop role statement. To back up all databases, you can use the PGAdmin tool. However, this is not recommended for the following reasons. The PGAdmin program exports all the databases, one after the other in a single script file. This prevents you from performing the parallel restore. If you back up all the databases this way, then the restore process may take a much longer time. The processing of dumping all the databases takes a much longer time than each individual one. So you do not know which dump of each database relates to a specific point in time. You must have a good reason to use the PGAdmin to back up all databases. The syntax is pretty much straightforward. You specify the command, which is the dump, which is the pg_dump all, specify the username which you want to use and dump, and then specify the redirection symbol and the directory or the file name. The parameters for the pg_dump all is similar to that of the pg_dump. However, the -w parameter is omitted to avoid typing a password for each database. So let's take a quick look at how you would back up all databases using the pg_dump all command. Once you have specified the command, just hit execute. If we do a ll, then we should see the backup SQL file. So if you view the file, you should be able to see the contents of the backup. And if you scroll through, you'd see all the scripts to recreate the databases. The other option to back up all databases is to use the pg_dump and back them up sequentially. To do this, you create a for loop statement that loops through all of the databases and back them up individually. So here I have a script that can do all of this for you. First, set the general directory where you want the backups to be stored. Then set the date format to append to your backup directory. Then create a directory for your backups. Then set the directory folder for your backups. Then change the directory to the base directory, and within that base directory, then you can create the backup folder. So what the backup folder will do is that it will only backup for the current day. And then you cd to the directory you created. This line covers the database to get all the list of databases, excluding the template databases. If you're supposed to execute this line only on the terminal, then you should see a list of databases that will be backed up. But first, execute these lines to create the directory. If you do a pwd to print the working directory, you will see the backup directory where the backups will be stored. If you execute the for loop and enter, then all the databases will be backed up individually. Let me clear the screen so you can see it better. You can then create a shell script and schedule it using cron to run on whichever schedule you want to automatically back up your databases. In the next lecture, we'll be taking a look at backing up individual tables and schemas. When you take a Postgres backup, the database is not compressed. If you have large databases, then this will definitely eat up a lot of your disk space. So there are two ways in which you can compress your backups. You can do the backups and then you compress them after the process, or you do the compression while the database is being backed up using the gzip utility. So to use the gzip command line utility when you're doing the backup, right, you first use the regular parameters, then after the database name you do a pipe gzip and then you redirect it to the output file, and it will compress your database automatically. Alternately, you could just wait till the backups are complete and then you run the gzip command to compress the database backups. So you can do a backup of the new database which you have created in your test environment. When you do a ll to list in what's in the directory, when you compare the zip backup compared to the database which we backed up in the previous lecture, you would see that the database size is a fraction of the size. If we do a backup of the DVD rental, which is a larger database, you will also observe a significant reduction in the size. You can also specify the verbose parameter, which is the -v, to display the output while the backup is being executed. You can also output the verbose message to a log file to show if any error occurred while you're doing your backups or restore. So if you do a list on the directory, you'd see that the database size is significantly smaller than the original backup. In the next lecture, we'll be taking a look at how you can backup databases on a remote server. So far in this course, we have been working with small databases, but what if you have a database which is 4 terabytes, 5 terabytes? Then this is where backing up your database may take a longer time, and you have two ways which you can manage this. The first one is to split your backup in multiple files. So Postgres allows you to split your backup in multiple files of a specific file size specified by you. So this makes it a lot easier to transfer like your databases to another host easily. To achieve this split, after you specify the database name for the backup, you use the pipe command, then specify split, then -b, and then the size of which you want your files to be, and then the name of your database. The second option is to do a directory backup, which we'll be taking a look at in the next lecture. Now that you understand how to complete a local backup, it's important that you know how to do a backup of a remote database. For instance, you may have a database running on a cloud infrastructure like AWS or Azure, and you want a dump of your Postgres database. How you would achieve this is that you do a backup of the remote database, because remember, with the cloud databases, well, the managed ones, you don't have access to the operating system like we just did to do a local backup. When doing a remote database backup, there are a few additional parameters that you need to take into consideration while you're doing so. You have the -h, which is the host name of the database host that you are connecting to, or the IP. You have the -p for the port, which is a database port which you are connecting to. The default is 5432. You also have the capital U for the username, -w for the password. You have the role parameter to set the role that you want to use to do the dump before completing the backup. The only difference is you're using additional parameters that will be able to allow you to connect to the remote server. In the next lecture, we'll be taking a look at how you can split your backup into multiple files. When you're managing Postgres databases that are huge in size and you're doing backups using just the PG dump only, these backups can take a long time, which will often impact users' performance throughout the business day, and this is not ideal. You want to avoid this type of situation. So with Postgres directory backup and parallelism, you can significantly decrease the amount of time the database backup takes to complete. So you'd use the -d parameter, but you have to keep in mind that the number of jobs that you specify for the parallelism should be less than the amount of CPU allocated for the server. So you can think about it like this: when you use the PG dump only, you have one little guy going out and taking a backup of the database. Now when you specify the -j and 3, now you have 3 guys out there taking backups of the database simultaneously. So in return, this will significantly reduce the amount of time taken to do a backup of your database. So what the parallelism parameter does is that it tells the database server the amount of job it needs to run to use and back up the database. You have to bear in mind that PGdump will open n+1 connections to the database, so make sure your max connection is high enough to accommodate all the connections. Another thing you need to note is that when you use the directory format, backups are compressed by default. Now let's do a demo on how to improve the performance of your backup. Now let's do a demo on how to back up your database using the directory format. So we're going to be taking a backup of the DVD rental database. And for the level of parallelism or the number of jobs, we're going to specify 2. Incorrect database, so let me change it to rental. That was a typo. If you list the files that are in the backup directory, you should be seeing multiple files for that database. And if you increase the level of parallelism again, then the job will complete even faster. So the DVD rental is a small database, so you won't be able to really judge the difference in time that it takes to complete the database. But nonetheless, I'll be doing it with 5 jobs. So if I do a list on the directory, then I should be seeing the number of files. And remember, when you're doing the directory backup, the files are automatically compressed. In the next lecture, we'll be taking a look at how you can restore your Postgres databases. So far in this module, you have learned how to back up your databases, but if you have never done a restore, do you truly have a backup? So let's go over how you can restore your databases using tools such as the PGArestore and the PSQL. It's very important to note that before you attempt to restore a database, make sure you drop all connections. So there are basically 2 ways which you can do restores, right? So if you have backed up your databases as a plain text such as a .sql file, you would need to use the PSQL to restore this database. If you have taken a custom backup like a tar backup or a directory format backup, then you need to use the PGRestore tool to do a restore of your database. If you are restoring a database and you want to ignore errors if any occur during the script, you can just simply use the PSQL command, specify the username and the backup file. However, if you want to stop the restoration of the database if an error occurs, then you would set the on-error stop parameter on. So if you had backed up a single database and you wanted to do the restore, you would have to specify the database name and then the backup file. So beside the PSQL tool, you can also use the PGRestore program. You can use this to restore databases backed up using the PGdump or the PGdump all. So with the PGRestore program, you have various options for the restoration of the databases. So for example, the PGRestores allows you to perform parallel restores using the -j parameter, and then you specify the number of threads or number of jobs that you want to use to do the restore. So each thread restores separate tables simultaneously, and just like when you're doing the backups, this will speed up your restore process significantly. The PGRestore option also allows you to restore specific objects in a database backup file. If you're migrating a database from a older version to a newer version, then you can use the PGRestore to do a restore of your database. So let's look at an example to use the PSQL to do a restore as well as the PGRestore. For this demo, connect to your server using the terminal, or if you're on Windows, connect using the command line. So in previous lectures, we have done several backups. So do ls to list the files within your directory, right? And here we have a backup that we use to back up all the databases. If you're supposed to run the PSQL command to restore the databases, you should get an error because they already exist. So as you can see, PG2 already exists, right? Also error and new DB already exists. But if you're in a large database, you would ideally want the database to fail and error because you don't want to restore a database and there are problems within that database and you may have missed the error in the log. So you'd want to quit that restore just in the case an error happens. So what you do in this case is that you would set the on error parameter to on. So now re-execute the statement. I missed one dash, So it didn't proceed to try and restore the other databases because it failed on the DemoDB creator. So if you are restoring a single database, you have to create the database first, or if you want to restore it to another database, you also have to create the other database that you want to restore the database as. So connect to PSQL and create a new database, and then restore the DVD rental as DVD rental prod, and then create a new database called DVD rental prod. You see the create database command, DVD rental. To restore the DVD rental as a DVD rental prod, then you'll specify the new database name in the PSQL command. So it's PSQL, right? And then specify -d for the database name which you want to restore the database backup to. You can also specify the -v to have the output displayed on the screen. So if you were to specify a database name without creating the database, then you'll get an error just like we'll experience now. So as you can see, database DVD rental PR does not exist. We also did a compress backup, so let's attempt to do a restore using the PSQL, right? And the compress backup file name. Now you'd realize you'll get an error when trying to do the restore. So when you're attempting to restore a database which you compress using gzip, you have to use the same gunzip command when you're doing the restore, right? So you'd have to specify the gunzip tool, specify the name of the backup file, and then you pipe it to the PSQL tool, and then specify the user that you want to restore as, and then specify the database name. So the database already exists, so let's create a new database for the restore. Create database, and we're going to call this compress restore. So exit, and now let's try to do a restore to the compress restore DB. Now the database was restored successfully. So the next example we're going to be taking a look at is the PGRestore command. In order to use the PGRestore to do a restore of a database, you need to have a custom backup, like a database backed up in the tar format or a directory backup. So the first restore we're going to do using PGRestore is a directory backup, since we took one previously. I expect this restore to fail because the new DB already exists. So unlike when you're using the PSQL, you can specify the -f for the directory backup because you'll get an error. So if I do the -f, right, you'd get an error stating that the -d and the -f cannot be used together. So remove the -f and then it restore. So as expected, I got the errors because the database already exists. Now let's take a tar backup of one of the databases and then restore that tar backup using the PGRestore. So I'm going to take a backup of the demo PG3 and save it as a tar file, right? So for the format, you're going to specify capital F -t, T for the tar file. Do a ls on the directory. Now you should see your custom format backup. So first create a database for this restore. So it's create database. So let's create database and call it tar restore. So let's do a restore of the tar backup to the tar database which you just created. So it's -d, specify the database name, and then the tar file. So this database is empty, so nothing much will be displayed. Also, if you try to do a -f for the file, then it will fail also. So when you're doing the restore with the PSQL, then you specify the -f to specify the file. Over when you're using the PGRestore, you do not need to specify the -f. Scheduling and automation is a very important aspect of database administration. And to achieve this in Postgres, one way you can go about it is using the PGAgent. On Unix systems, PGAgent runs as a daemon, and on Windows it runs as a service. In most cases, the PG agent will run on the database server itself. So for this reason, PG agent is not automatically installed when you install the PGAdmin. So basically, the PG agent can be installed on a separate server from your database server. It also has more powerful scheduling capabilities than cron, which is often used because this is specifically built for Postgres tasks. So for example, PG agent can schedule multiple steps without a batch script or without repeating the command. In the next lecture, we're going to be taking a look at how you can install PG agent on Unix or a Windows system. To install PG agent daemon on a Unix system, normally you need to have root privileges. To install the agent on Ubuntu, you would use the sudo apt install PG agent. Remember, this will vary per Unix system, so consult with your system documentation. For installation on Windows, PG agent is available in a pre-built installer, so you can use the stock builder application to download it and install. If you do it this way, the service will be automatically created for you and you don't have to follow the route of using the command line for Windows. So now we are going to be installing PG agent and Ubuntu server. Once you have connected to your database terminal, issue the command to install PG agent. This may take a few minutes to complete. In the next lecture, we're going to be taking a look at how to configure PG agent for your database. Now that you have installed PG agent, you are now ready to configure your database for the use of PG agent through PGAdmin. Before using PGAdmin to manage the PG agent, you must create a PG agent extension in the maintenance database. So expand your Postgres database, right-click extension, and select Query Tool. Then execute the command create extension PG agent. So when you refresh your Postgres database, it's important to know that a PGAsQL is required before you create the PG agent extension. If not, you'll get an error. The next step is to set up a PG agent as a daemon so your jobs can execute successfully. So now that you have installed the PG agent and configure your database through PGAdmin, the next thing you need to do is set up the PG agent daemon on your server. Now the daemon is pretty much a program that's run in the background and execute your tasks. In order to set up the PG agent daemon, you need a PostgresSQL connection string so that when you schedule your job, the process will execute appropriately. So in this case, you're going to be setting up the PostgresSQL libpg connection string. So it's a connection string that is user specific that connects with certain parameters that you specify. You can learn more about this connection function in the PostgreSQL documentation. So your connection string will provide the credentials of your host, the database name, and the username. So for the setup, we're going to be using a Unix domain socket. It is a data communications endpoint for exchanging data between processes executed on the same host operating system. Now for the Unix, you don't need to specify the password of the username. This string will be appended to the PGAgent command to initiate the daemon. So execute the following command in your terminal, right? If there is no error output on your screen or you don't receive any connection error, then the connection string was successful. So now we're at the fun part of this module. We're going to be creating a job to insert data every minute in one of our existing tables within the new database. The data which is in the new DB now was stored from the DVD rental database. So you can generate an insert statement for any of the table you want by right clicking on the table and then select script and then insert script. And then modify the script to set the parameters that you want. So I'm going to execute this script and ensure it is executing successfully. Now scroll down to the PG agent, right click and select create PG agent job. Specify a name for the job. And then for the job class, you can select data import. For the steps section, you're going to create the steps that you want to run in the job. In this case, we're going to add only a step. So select the plus icon to add a row. Then specify a name for the step. Then in the edit section, click the edit row section to make changes to the job. So you have two kind of tasks that you can use. You can use SQL and you can use batch. We're going to be using batch. You can run on a remote server, right? Or you can run on a local host. Say it's local host. Select the database that you want to execute the job against. And then on error, we're going to keep it as fail. On the code tab is where you specify the SQL code to be executed. Now you can use this to do pretty much any form of SQL, whether you want to delete or update, execute a store procedure, you name it. You can use it to schedule your task. Then select save. Oops, I'm not done, so I'm going to have to re-head it. Select properties. Now on the schedules tab is where you're going to set the schedule for the frequency of which you want the job to execute. Select the plus icon to add a row. Specify the name for it. So you can give it any name you want. I'm going to execute it every minute. So I'm going to just call it insert minute. Edit row. Specify when you want the job to start, the date. And you can leave the end date as null, or you can set a date when you want the job to end. So I'm going to put the 18th. And feel free to leave a comment for your job step. On the repeat section is where you specify when you want the job to be executed. You can select the specific days you want the job to run, or you can select all, right? Let's X that out. You can also select the month day, whether you want to execute on the 1st, the 3rd, the 4th. You name it. For the month, you can do the same. However, we're just going to set it for every minute. So to do it every minute, you're going to select all and then select save. Now query a table to validate that the data is inserted successfully. So let's execute. If I scroll down to the bottom of the table, see where the records are inserted. So I just refresh and my total rows went to 5, so another record was inserted. To view the execution history, select the job and then select statistics. So the status is saying success and it shows the time it was executed and the duration. If you view the SQL tab, you'll see the list of SQL statements that was generated to create the task. When you select properties, you'll also get a brief overview of the status of the job. You can enable and disable. You can also query the tables within the PG catalog, expand the PG agent scheduler, and then you should see the list of tables that were created when you created the PG extension. So you can right click and view data for any of the tables. There is no exception thus far. So let's view schedule, view data, all rows. And this is the one schedule which was created. So you can use the PG agent to schedule almost any task you want within your database, and you don't have to go through the struggles of using cron. Postgres databases require periodic maintenance known as vacuuming. For many installations, it is sufficient to let the vacuuming be performed by the auto vacuum daemon, which we'll discuss later on in this module. You may need to adjust the auto vacuuming parameters to obtain the best results for your situation. You can also supplement or replace the daemon's activity with manually scheduled vacuum commands by using PGAdmin or cron to schedule scripts. In order to set up manually managed vacuum properly, it's essential to understand the concepts that we'll be covering in the upcoming lectures. Postgres vacuum command has to process each table on a regular basis for the following reasons. The first one is to recover disk space occupied by updated or deleted rows. Second is to update statistics used by PostgresSQL query planner. Thirdly, to update the visibility map, which speeds up index scans only. And fourthly, to protect against the loss of data loss due to transaction ID wraparound. Each of these reasons dictates performing vacuum operations of varying frequency and scope, which we'll be taking a look at shortly in upcoming lectures. So there are two variants of vacuum. You have the standard vacuum and you have the vacuum full. The vacuum full can reclaim more disk space but runs much slower. On the other hand, the standard form of vacuum, that means you just run the vacuum command only, can run in parallel with your production operation commands such as select, insert, update, and delete. These functions will continue to operate normally, though you will not be able to modify the definition of the table with commands such as the alter table command while it is being vacuumed. However, it's important to note that the vacuum full requires an access exclusive lock on the table while it is working on it. Therefore, it cannot be done in parallel with other use of the table. So it would be a good idea to strive to use the standard vacuum command and avoid doing a vacuum full. In Postgres, an update or delete of a row does not immediately remove the old version of the row. This approach is necessary to gain benefits of the multi-version concurrency control. The row version must not be deleted while it is still potentially visible to other transactions. But eventually, the outdated or deleted row version is no longer of interest to any transaction. The space it occupies must then be reclaimed for reuse by new rows. This will avoid unbound growth of the space requirements. This is done by running the vacuum command. So what the standard form of vacuum does is that it removes the row version in tables and indexes and marks the space available for future reuse. However, it's important to note that this will not return the space to the operating system. On the other hand, vacuum full actively compacts tables by writing a complete new version of the table with no dead space. This minimizes the size of the table, but can take a long time to complete. So keep in mind that it will require extra disk space for the new copy of the table until the operation is complete. So should you use vacuum full or standard vacuum? The usual goal of routine vacuuming is to do standard vacuums often enough to avoid needing a full vacuum. The auto vacuum daemon attempts to work in this way, and in fact it will never issue vacuum full. Although vacuum full can be used to shrink a table back to the minimum size and return this space to the operating system, there is not much point in this if the table will continue to grow again in the future. Thus, moderately frequently standard vacuum runs are a better approach than infrequent vacuum full runs for maintaining heavily updated tables. So it's better to do it incrementally than wait overnight to do a schedule. You can choose to schedule vacuuming yourself, for example, doing all the work in the night when the load is low. But the challenge with vacuuming according to a fixed schedule is that if a table has an unexpected spike in update activity, it may get bloated to a point that the vacuum full is really necessary to reclaim this space. So using the auto vacuum daemon alleviates this problem because the daemon schedules vacuuming dynamically in response to update activities. So it's unwise to disable daemon completely unless you have extremely predictable workloads. The Postgres query planner relies on statistical information about the contents of the tables in order to generate good plans for queries. These statistics are gathered by the analyze command, which can be invoked by itself or as an optional parameter in vacuum. It's important to have reasonable accurate statistics, otherwise poor choices of plans might degrade database performance. The auto vacuum daemon, if enabled, will automatically issue analyze command whenever the contents of a table has changed sufficiently. The daemon schedules analyze strictly as a function of the number of rows inserted or updated. It's important to note that it's possible to run analyze on a specific tables or even just a specific column of a table. As best practice, it's usually best to analyze the entire database because it's a very fast operation. So what analyze does is that it uses a random sampling of the rows of the table rather than reading every single row. So let's take a look at a quick example for you to see this in action. In order for us to simulate how the analyze work, let's first create a table. And by default, auto vacuum is enabled. However, we could also disable the auto vacuum in the create statement, but we're going to use the alter table statement to disable the auto vacuum. We can now check the vacuum status on the table. It should be saying vacuum enabled false. So now let's do a select on the table to confirm that there is no data in the table. Next, we're going to execute the explain statement, which generates the execution plan for the query, right? So let's execute the explain statement and the select all from person. So if you look on the number of rows, it's guessing and the table doesn't have any rows in it. So the optimizer will generate an inefficient plan for the table. Therefore, the query will be slow. So if you look carefully, it's saying person has 2,260 rows. But in fact, it is 0. So it's generating an incorrect plan because the optimizer doesn't know anything about the insert statement because we disabled the auto vacuum. You can also confirm the number of tuples in the table by checking the PG class table. So as you can see, number of tuples 0. Now let's also insert 1000 records within that table. Now let's check the status on the table again. So even though we have inserted 1000 rows in the table, the statistics doesn't know anything about it. If we do a count on person again, then you should be seeing 1000 rows. Now let's execute the analyze command and person and you'll see the difference it makes. So let's check the statistics on the table. Now you're seeing that person has 1000 rows. And if you do explain on person, you should see an estimated rows of 1000. So now let's re-enable auto vacuum on the table by setting the auto vacuum parameter to true. So what will happen in the background is that the auto vacuum daemon will be running in the background and issuing the analyze command based on the number of rows inserted in the table. Now let's insert some additional records. So now we should have 2000 rows within that table. Now let's check the statistics. This may take a little while to update, right? However, it's showing 2000 rows because it's pretty efficient. So that's how the auto vacuum daemon works to help improve performance of your database. Vacuum maintains a visibility map for each table to keep track of which pages contains only tuples that are now visible to all active transactions. This has two purposes. First, vacuum itself can skip such pages on the next run since there is nothing to clean up. Secondly, it allows Postgres to answer some queries using only the index without referencing the underlying table. Since Postgres indexes don't contain tuple visible information, a normal index scan fetches the heap tuple for each matching index entry to check whether it should be seen by the transaction. An index scan only, on the other hand, checks the visibility map first. If it's known that all the tuples on the page are visible, the heap fetch can be skipped. This is most useful for large data sets where the visibility map can prevent disk accesses. The visibility map is vastly smaller than the heap, so it can be easily cached even when the heap is very large. Postgres MVCC transaction semantics depend on being able to compare transaction ID numbers. A row version with an insertion ID greater than the current transaction XID is in the future and should not be visible to the current transaction. But since transaction IDs have limited size of 32 bits, a cluster that runs for a long time, more than 4 billion transactions, would suffer from transaction ID wraparound. The XID counter wraps around to 0, and all of a sudden, transactions that were in the past appears to be in the future, which means their output become visible. In short, this can lead to catastrophic data loss. So to avoid this, it is necessary to vacuum every table in the database at least every 2 billion transactions. Periodic vacuuming solves this problem by marking rows as frozen, indicating that they were inserted by a transaction that committed sufficiently in the past that the effects of the inserting transaction are certain to be visible to all current and future transactions. So in previous lectures, you'd have an idea what the auto vacuum daemon does. Its purpose is to automate the execution of the vacuum and analyze commands. When enabled, auto vacuum checks for tables that have had large enough inserted, updated, or deleted rows. The auto vacuum daemon consists of multiple processes. There is a persistent daemon called the auto vacuum launcher. As the name suggests, it is in charge of starting auto vacuum worker processes for all databases. The launcher will distribute work across time, Each worker process will check each table within the database and execute vacuum and/or analyze as needed. To view the settings for auto vacuum, you can view them in the Postgres config file, query the PG settings table, or from PGAdmin, select your server and then select configuration. To keep your database up and running optimally, from time to time you will need to rebuild indexes. In Postgres, this can be done by issuing the reindex command. You can recreate index for a table, schema, database, and recreate the index. The Postgres reindex statement first drops all the indexes, then creates all. The command requires an access exclusive lock by default, hence it's often preferable to execute it with its concurrently option, which requires only a share update exclusive lock. You can schedule reindexing using PGAgent, as well as you can schedule scripts using cron.
I am thrilled to extend my heartfelt congratulations to you on the successful completion of the PostgresSQL Database Administration Essential Training. This is a remarkable achievement that reflects your dedication to continuous learning and professional development. Your commitment to mastering the essential skills in PostgresSQL database administration is truly commendable. Acquiring expertise in this area is not only a testament to your hard work but also a valuable asset that will undoubtedly contribute to your professional growth. As you embark on applying your newly gained knowledge and skills, I have no doubt that you will excel in your endeavors and make a positive impact in the field of database administration. Your commitment to excellence and passion for learning are truly inspiring. May this accomplishment open up new opportunities for you and pave the way for continued success in your career. Keep up the fantastic work, and I look forward to witnessing your continued achievements in the future. Once again, congratulations on this significant milestone. Your dedication has truly paid off.